Hello, today we're going to be working on the Unit 3 review so that we can prepare for that final exam. The final exam is 95% probably over Units 3 and 4. So there might be a few things that kind of carry over, but today I'm going to work on the Unit 3 review A. It should be on page 124, I believe it is, of your in your workbook. I have a few problems from the review B as well that I'll work on as extensions, but this is mainly what I'm going to be doing. So let's start here with number one. It says, which savings account is better? So I gave you a simple account and three other accounts that are compounding monthly, compounding daily, and compounding secondly. And they all have different interest rates. And so to be able to compare them, I don't see any money. And so if there isn't any money, then we're going to use the formula for effective rate. Okay, I believe this is in 3.2 or 3.3 section. And the effective rate formula is this. It essentially puts all four of these different investments and savings accounts into an apples to apples comparison. Okay, so it'll give us an interest rate that would return the same simple interest here. So we're basically going to do the effective rate for B, C, and D and compare it to 5.01 in the simple interest. Okay, so letter B is going to be the effective rate here, 0.0498 over 12 to the 12th, because it is compounding monthly. Okay, so that's why these are 12. And then we're going to subtract 1. And show you what that looks like in Desmos. And it's going to be parentheses 1 plus 0.0498 divided by 12 parentheses up to the 12 minus 1. Oops, this should be 12. So the effective rate for the first one is 0.05095, which is 5.095%. Okay. And the second one is for C, and that's going to have a similar formula. Oops. Except for the interest rate is 0.0496. And it says that we are compounding daily. So we're going to use 365.25. And that means our exponent needs to be as well, 365.25. And that means it's right here, 0.0508. Oh, 5.085. So 5.085%. And then 1D is 0.04 0.04905. There's a dollar sign there, that should be percentage. symbol. So that's just 0.0490. And we're compounding secondly. Wow, secondly, we have to figure out how many seconds in a year. So there are 60 seconds in a minute, 60 minutes in an hour, times 24 hours in a day, times 365.25 days in a year. So there are 31,557,600 seconds in a year. So we have to use that as our N, 300,557,600. And then in our exponent 2. Oops. So 31557,600. So that comes out to be 0.0502. So I'm going to go back and share my paper with you so you can see what we've gotten. So here's my work for all three. And so now they're all in, and what would have to be a simple interest rate to return to give you the same return as these different compounding. So on B, I would have to earn 5.095 simple interest to compete with this compounding. And so my effective rate is the highest for letter B, so that's going to be my choice. And here's my computation down here for how many seconds in a year. So if I'm asking you to compare different savings accounts, you definitely are going to have to use this effective rate because there isn't any money to do and find the future value. So let's look at question number 2. It says, how much interest will you earn if you invest $6,000 in an account for 20 years that earns 3.24% interest compounded continuously? Okay. So how much interest is my end result? That's what I really want to know. So I have to know my future value to find that. So my future value, A, is going to be P times E to the RT, where R and T are in the exponent. So my P is the amount I'm investing, which is $6,000. E is the irrational number that is in the calculator. Our rate is at 0.0324, and our time is for 20 years. Okay, so my formula looks something like this. 6,000 E to the R, which is 0.0324 times 20. So I'm going to put this in Desmos here. It's going to be number 2. And take you to my Desmos. So here it is in Desmos. We're going to have 6,000 E, and notice it puts it in italics because it knows that we're using the irrational number, and I'm putting 0.0324 multiplied by 20 in a parentheses, so it knows that that multiplication, this product right here where my mouse is in the exponent, all of it. So it looks like after 20 years, I'll have $11,470.28 in my account, but the interest is taken by taking my future value and subtracting my P. Okay, so that means my interest is going to be taking that $11,470.28. So 11,470.28. Oops. 11,478.28 and subtracting that $6,000 I started with, and that will tell me how much interest I actually earned, which is $5,470.28. Wow, that's awesome. I'm going to show you my paper so that you've got that. That's some good money. Because compounding continuously is the best type of compounding you can get. For sure. Okay, let's move to question 3. So question 3 says, should you make a down payment of $2,000 when purchasing a $15,000 car with a 60-month loan at 7.35% interest? Well, of course you should make a down payment. So I think that was written incorrectly. Let's find the monthly payment. Let's just see that this is asking us to find a monthly payment for this vehicle. Let's say you went to buy this car and they told you what the payment was going to be, and you just want to make sure that what they said is really true, because sometimes there's fees that you don't know about, and this is how you might find that. So we first need to have P, which is the amount borrowed, which means that we're going to take the cost of the car, $15,000, and subtract the down payment. So I'm actually only borrowing $13,000. So my monthly payment formula, M equals P, and then we've got our rate divided by 12 because it's monthly payment, so that's going to be 12. And then over 1 minus 1 plus R divided by 12 to the negative NT. So we're borrowing $13,000, and the rate is 0.0735 over 12 minus 1 plus 0.0735 over 12 to the negative, and then it said 60 months. So this right here is if you have 12 monthly payments and then the number of years, and they already told us the total number of months. So this is my total number of payments. So that's going to be 60 because that's what they told us here. So let's go to Desmos to find out. This is number 3. And so our number that I like to get my fraction going, and then I'll go back up and adjust this up here and put my 0.0735 divided by 12 together. So this is what my monthly payment formula should look like, and it looks like my monthly payment is going to be $259.57. So $259.57 is my monthly payment. Okay, now if I wanted to figure out how much I totally owed on that, I would, or the total that I'm going to pay for my car. So I'm just going to make a note here. Like I said, the question on this was kind of goofed up, so I'm just kind of going with this car thing that we learned about. So thinking of some things I might ask you on the final exam might be total paid for the car. And so that would be, let's just say that would be equal to total payments, right? Plus your down payment. So let's see. So our total payments would be 60 payments. They told us we're going to make 60 monthly payments times that payment of 259.57. And then I'm going to put a parentheses around this. And then we have to add in our down payment because that was part of what we spent, but we put that at the beginning. So it looks like my total paid for the car is $17,574.20. So let's go to question number 4 here on our paper. So question 4 is school loan question. So it says you receive an unsubsidized loan for $23,000 at 4.35% interest to pay for your degree. If you are in school for 2 years and defer payments for 3 months after school, what is the total cost of your education? So you receive an unsubsidized loan. So we have to remember unsubsidized means that there's interest while we're in school. So interest in school. Because the school is, the government is not subsidizing, they're not paying for that interest for you. Okay, so we have to figure out how much interest while we're in school first. So interest while in school. So that means on my, let's say I'm taking the loan out right up front. So it's not really how it works. When you go to school, you get certain amount of loan comes, you borrow a certain amount for the first semester and then a certain amount for the second semester and so on and so forth. So we're assuming that you borrow this $23,000 up front. So your interest in real life wouldn't be this much, but we're going to do the worst case scenario. So 23,000 borrowed up front at 0.0435. And remember, this is simple interest, and simple interest is A equals PRT, right? I'm sorry, not A, but interest equals PRT for simple interest. And so we have what we borrowed, the rate at which we borrowed it at, and then the time is 2 years plus 3 months. So that would be 27 months. Usually it's deferred for 6 months, but this says 3 months. Okay. So this is not 27 because this has to be in years. So 27 divided by 12 is the number of years. 2.25 years. So this is 2.25. So I'm going to Desmos for a moment and type in 23,000 times 0.0435 times 2.25. And don't worry, I'm going to share this whole Desmos with everybody as well. I will put the link in ChatNet for you all. Okay, so our interest comes out to be a total of $2,251.13. Okay, so when we go to graduate and we go to start making our monthly payments, 3 months after graduation. That's what they told us, 3 months after graduation. I have to figure that out. So my monthly payment is what I'm going to figure out here. But I have to find out how much I'm gonna owe. I owe 23,000 that I borrowed plus interest while I was in school, $2,251.13. Because if I didn't have money to pay that while I was in school, that accumulated. So I owe 23,000 plus 2251 and 13 cents. So my monthly payments begins with this $25,251.13. So 25,251 and 13 cents. And my interest rate is still at this 4.35%, so 0.0435 over 12. 1 minus 1 plus 0.0435 over 12. And remember that the total number of monthly payments for a college school loan is always 120. So this is a negative 120. It's 10 years. Okay, so we kind of assume that. So let's go to Desmos. The cool thing in Desmos is that the monthly payment formula that we use is the same every time. We just have to change all of our pieces. So I'm going to go up here and copy this one and then just use it down here and just edit everything. So that's going to be 120 payments, and my interest rate is 0.0435. So that's, I just have to edit that. And I have to edit what I'm borrowing here, which is 25,251 and 13 cents. And then I have to edit my interest rate down in the denominator as well. Okay. So that's super interesting because my payment is not much different than from the car loan that we borrowed up above, which is interesting. So that monthly payment is $259 and 88 cents. Now, they did ask us for what is the total cost of your education. So let's just go back to our paper for a moment. They're asking us for the total cost of your education, which means total cost of education. I didn't have any money down as a down payment, but I do have to make this payment. Let's say I make that same payment for my 120 months, my 10 years. So my monthly payment times 120 payments. So don't worry, I will save my work in Desmos. So 259.88 times 120. And that becomes, what I owe is 31. I will have paid $31,185.60 after the 10 years. That is the total cost. So that's a lot. And considering I only borrowed really 23,000 was my loan, right? I had this interest while I was in school plus the difference. So if you take the 31,185 and subtract the original 23,000 that I borrowed in loans, I had a total of $8,185.60 just in interest paid over the 10 years of payments plus the 2 years I was in school. So that's a lot. That's a lot. Okay. So if you flip the page to question number 5, we're going to skip because, well, let's see. I think maybe we can do this. Calculate the average daily balance for the following credit card if the ending balance in February was $211.14. If the monthly interest charge is 2.5%, calculate the new balance in April. Okay, so let's take a look here. Okay, so we're working on this credit card balance, and the average daily balance means we have to find, we started with this balance of $211.14, and then we made some purchases. So the only thing we have to take notice on is right here on March 11th, we did have a payment. So from February 1st, 2nd, 3rd, 4th, for 4 days, we had this balance of $211.14. Okay. And we can see that right here. $211.14 we had for 4 days. And then we made a purchase of $12.21. And so our new balance is going to be $14,032 and I'm sorry, $1,432.14. And that's for 5 days. So what I did was you should go through and find your totals, daily totals, and then we'll figure out how many days in between each one, just like we did in the book. Remembering on this one, on March 11th, again, you're subtracting $633.60 because you made a payment. So I'm going to show you how I put mine into Desmos here. So in Desmos, in the first column, I went through and found my daily balance as I made a purchase. This first one here was my first 4 days from the last month. Then I made a purchase. And then I made another small purchase, and then I made that big payment. And so now my balance is $867.20. Then I made a purchase of $59.63. On the 16th, we made another purchase of $200 and a purchase of $1.25. So that's what gets us to $1135.57 for 2 days. And then on the 13th, which actually should have been before that, should have been only right from the $867.20 to the $874.69. There was a purchase of $749. So there were a few of them that were out of order. And then down at the bottom, there's the March 18th. Don't worry, if I give you one of these on the final exam, there won't be as many transactions and they won't be out of order, because on your bank statement, it would never follow like this. But the key is you have your balance, and then your Y1 is going to be the number of days that you were at that balance. So I was at my first original balance for 4 days, and then my next balance for 5, my next balance only 1 day, and so on and so forth. And your number of days should add up to be the number of days in your month, which in this case is 31, because oops, let me take you back to my paper, because this was my balance at the end of February, and now we're talking about March. And so there's 31 days in March. Okay, so then in Desmos, let me take you back to Desmos for a moment. So in Desmos, we are going to take the average. So we're going to total our X1 times Y1, and then we're going to divide by 31 because there's 31 days. Okay, so my average daily balance is $1,399.75. But it says they want us to calculate the interest charge and then calculate the new balance. So I'm going to just make a note here in Desmos that interest charged is going to equal the average daily, average daily balance times the rate. So ours is going to be $1399.75 times the daily rate, or the interest rate of 0.025 for the month. So they're charging us that much interest. And so our new balance on March 1st will equal my ending balance at the end, which was $2,333.83, plus the interest that I have to pay on my average daily. So that's going to be 2,333.83 plus $34.99. So $2,368.82. Let's go back and share my paper on that. Okay, so there is my work. My new balance is my ending balance, which was my ending balance on the last day of March, which is $2,333.83 plus the interest on my average daily balance. So here's my balance as of April 1st. You know what? In Desmos, I put as of March 1st, but that's April. I will change that. Fool's Day. That's a big one. Okay, let's flip to problem number 6. So taxes, you all just finished this really in your income unit project. You did a great job. So it says, what are the 2018 taxes owed of someone who had a taxable income of $32,456? So this is 2018 is what we're looking at. So their taxable income falls into this category right here. Okay. So 2018. So that means we're not going to charge them tax on the entire income at 12%. It means the first $9,525, we're going to only pay 10%. 9,525, we're paying 10%. So that's going to be $952.50. This is going to be our tax we're going to calculate. And then at the 12% is going to be our salary that falls in there, which is the $32,456 minus the top of the previous category, 9,525. And we're going to pay 12% on that amount. Okay. So that amount comes out to be $22,931, and we're going to pay 12% on that amount. And so that amount of tax is $2,751.72. So if I add these together, my total federal tax in 2018 would have been $3,704.22. Now, for practice, you could have said, well, what would my 2017 taxes been? Because if they had a taxable income of $32,456, they would have been in this bracket. But notice in 2017, the top bracket, the very first bracket at 10% went up to 9,325. Now in 2018, it went up to 9,525. So that's good. So there's more in 2018 that you're getting taxed at this lower amount. And look at the next bracket, the next level in 2017, the very next level that you're going to pay is 15%, whereas in 2018, it's at 12%. So in 2017, you would have paid $932.50 for the first 10%. And then the difference at 15% would have been $33,469.65 for a total of $4,402.15. So you would have definitely paid much more, about $700 more in 2017 than in 2018. So tax cuts were good. Tax cuts are always good. It gives money freed up for you to donate in other areas that you want to donate. And I think that's great. I love to be able to make that choice on my own. Okay. So there's 2 pages left of, oh no, there's one, just one problem left in this review. And then I think there's an extra problem that I would like to do in the part B. So let's look at number 7 here. It says, which mortgage is better when purchasing a $225,000 home? A 15-year mortgage at 4.21% with 0% down, or a 30-year mortgage at 4% with 20% down? Okay. So let's look at the first one here. So this one was 0% down. You have got your monthly payment here that you are borrowing at $225. You're borrowing the whole thing. And 0.0421 over 12 is your interest rate. And then 15 years, your total number of payments, and it's going to be 15 years, so 180 payments. Okay, so when we type this in, again, it's our monthly payment formula that we've used several times today. And it's going to be in, I'm just going to add a little note here. And this is number 7. Okay, so I'm going to go to Desmos and share with you how to type this in. So we need to edit this because this is I copied from another problem. So we borrowed the full 225,000, right? And my interest rate is 0.0421. And then I have 180 payments. So 180 payments. So my monthly payment is going to be $1,688.08. But it says, which mortgage is better? So we have to figure out our total cost. So what are we going to total our total payments? So our total payments, total cost to purchase, because there's no down payment, it's just going to be the total of our payments. So we're going to have 180 payments times 1,688.08. So 1,688 and oops, 8 cents times 180. So that's going to be the total cost of purchasing this home is $303,854.40. Plus, we do have to make the comment here. I'll show you my paper here. This is going to be our total cost, but we have to remember that PMI that we found out when we were working on our unit project for the home purchase, that if you don't have any down payment, if you don't have 20% down, actually you need 20% down. So if you have 15% down, that's great, but you're still going to have to pay PMI until you've reached the point of which you only owe 80% of your cost of your home. Okay, of which means that 80% that you owe, so that means you have 20% down. So here they would have to pay PMI until they get down to that 20% down value, which is called the loan to value ratio needs to be 80%. To not have to pay this PMI. So we don't know exactly what that would be. But let's look at the other mortgage. It's a 30-year mortgage at 4% with 20% down. So the down payment here would be the 225,000 times the 0.2 for the 20% down. So they're going to put 45,000 as a down payment. So that means their amount to borrow is 225,000 minus the 45,000 that they're putting down. So they're borrowing 180,000. Okay. So their monthly payment, I'm just going to go straight to Desmos and copy this over. So I'm going to copy this formula and put that in. And this time they're borrowing it for 30 years. So it's going to be 360 payments. We have to remember that they have a little bit lower interest rate because they aren't borrowing as much. And they're only borrowing 180,000. Oops. I'm going to do a back arrow here and mix this up. Okay. So 180,000. Okay. 0.04, 0.0. Okay. And then get my interest rate correct. Okay. Okay. So it looks like my monthly payment is $859.35. So it's definitely less. It's like almost half because I am taking twice as long to pay it. But I did put that down payment. So let's go here and let's go back to our paper here. So we're going to figure out our total cost to purchase. We have our 360 payments of $859.35 plus my down payment of 45,000. So it looks like my overall cost for the second one is $354,366, which is much more than up here at the $303,854. Now PMI on this loan, I'm guessing maybe like $75 a month. So if they had to pay that $75 a month for, let's say, 5 years, so 75 times 60 payments, that would be like $4,500. So even paying PMI, they're going to pay less by just paying the bigger payment, a slightly higher interest rate, and only taking 15 years to pay it off. But you need to have double the amount per month available, right, for that monthly payment. So that's a big deal, that monthly payment being double. Okay. In this review, there's something that we didn't touch on, and I would like to do that on the other review. So if you can go to the Unit 3B, Review B, to page 136, I would like to go over some things on the stat table because I think that's valuable. So I think that's important. So number 17 there. And I don't know why it wasn't part of the review, but it just wasn't. Okay. Okay, we're gonna complete this from, it's number 17 from Unit 3 Review B. Because there isn't one from the Review A over the stock market. So it says the following stock table lists the current stock information on April 3rd, 2019. So wow, right after we all came home for COVID, or actually, yeah, right after, for Twitter. Use the table to answer the following questions. What was the value of the stock yesterday? So it was, the previous close was 279, I'm sorry, 272.79 cents. And it's probably was going up because everybody's sitting at home on their phone. Determine the number of shares issued using the market cap. Okay. So we have to find the market cap, which is right here. So 120.114 billion, right? And that's made up of the number of shares, S, number of shares, times the current price, 274.46. So number of shares is going to be found by 100 and taking the market cap and dividing by the current price, 274.46. So let's do that on Desmos. So I'm going to do 120.114 divided by 274.46. Well, I want to show you, let me show you this on Desmos. So this is in billions because I didn't multiply this times billions, but I'm going to go up here and I'm going to multiply my market cap by billions because it just put a B there to let you know that there's that many billion, 120 billion shares out there. So I'm going to times that by 1 and then 3 zeros for the millions, 3 for the thousands, and 3 for the ones. So this is the hundreds, thousands, millions, and billions. So when we divide by 276.46, we get this number here. I'm going to write that out as 434,532.9. So almost 434,000. I'm sorry, 434,471,532, almost 33 shares. I'll share my paper with you. Right here. So you're taking the market cap and you're dividing by the current price to get the number of shares out there. Okay. Part C says, to purchase 500 shares at the current bid price. If you use a broker, so the bid price here is 274.01. If you use a broker that charges 1.5% commission, how much does it cost to purchase the shares? So we are purchasing 500, and we can purchase 500 because they are willing to share up to 1,000 at a higher price. So we're gonna get them at the bid price. So we're gonna multiply 800 plus that cost 274.01 times 800 times the commission of 0.015. So I'm going to go to Desmos and figure out that. So first I'm going to do the 274.01 times the 800 shares plus, whoopsie, thought I was typing, but I wasn't. 274.01 times 800 shares plus the, oops, plus the 274.011 times the 800 shares times the 0.015 for the commission. So it's going to cost us $222,496.12 to buy those shares. That's a lot of money. Okay. So that's going to be our cost to purchase the shares. Now it says, suppose you decide sell your 500 shares. Oh, it's supposed to be 500. I goofed up. This should be 500. 500. So it's not going to be that much money. He's 8. Okay. So it's going to cost me $139,060.08. Still quite a bit of money. Okay, so now suppose you decide to sell your 500 shares 2 years after purchasing, and the current value is $380.46 a share. Wow, that's a lot. It went up. Calculate your annual rate of return if you are charged a 1% commission for selling. Okay. So first we have to find the proceeds. So it's going to be our number of shares, our 500 shares, times the selling price of 380.46, subtracting the commission, right, which is the 500 times 380.46 times the commission. And this time it's only 1%. And then our net proceeds, we'll do in a minute. So let's go back to our Desmos here. And let's just put a little note that this is our proceeds from selling stock after 2 years. Okay. So 500 times 380.46. And this time we have to subtract money because this is money we're getting. So we have to subtract the commission this time. 500 times 380.46 times 0.01. Oops. There we go. So our proceeds are $188,327.70. And our net proceeds, let's just make a note here. So our net proceeds are the proceeds subtracting the cost to purchase. So we have $188,327.70, subtracting the original cost of $139,000. $60.08. So our net proceeds are $49,267.62. Okay. I'm going to show you my paper so you can see what I wrote down. Here's my net proceeds, my net proceeds, which is my proceeds right here, subtracting the original cost right up here. But it's asking us to calculate your annual rate of return rate. So that means that's our percent profit. So it's our profit, 49,267 divided by, so it's our net proceeds divided by our cost. So this is going to be our rate of return. So we're going to divide that out in Desmos. So we've got 49,276.62 divided by 139,060.08. So we made 35.44%, but we had it for 2 years. So we really need to divide this by 2. 35.44 divided by 2. So it's really about 17.72% each year. It's our annual rate of return. Pretty awesome if you can get that. But you had to have $139,060 up front, right, to make the original purchase, which is kind of a bit. So catch me back for the Unit 4 review as we get ready for our final exam next week.